Hello. Hi, everyone. Thanks for coming tonight. So we've got two talks on tonight. We've got Zach and Amy. Zach's going to be doing a more talking about the creative side of AI and JavaScript. And yeah, we've got two more events coming up on the 9th and the 14th of May, so do sign up for them as well. And yeah, if you could all welcome Zach.
Hello? Yep, working? Perfect. Hey everyone, nice to be here. I'm Zach Ioannidis. I'm a technologist, currently freelancing, coming from the background of data visualization. Thanks Asim and Elle for organizing this. It's really nice. It's my second event that I've been here. Today I'm going to talk about a contrast between the digital and the physical space, and this is something that I'm currently exploring through the context of an installation that I'm building. I'm more accustomed to prototyping on the web, so I'm going to be showing you my whole process of how I got to where I'm at, and right before kind of taking it and physicalizing it and putting it into space. So yeah, my background is in computer science. And I wasn't really feeling it until my second year when I started looking at the stuff that the New York Times were doing in terms of multimedia, journalism, and visual storytelling. And that's when I thought, OK, I'm more interested in the visual output of this kind of work, and I can take my skills and kind of use them towards this purpose. So that's kind of how I ended up doing the kind of stuff that I'm doing. And I'm really interested in the kind of coexistence between machine learning and creativity, how we can use tools and exploratory platforms and frameworks to augment the creative process. And I think these things that I'm going to show you today have a little bit to do with that. So as part of my thesis in my second year of university, I was kind of looking at ways of physicalizing data coming from the quantified self. And this was still in 2016, so the concept of the quantified self was on the tail end of cool, right before we got everything on our phones, step counters, heart rates, et cetera, et cetera. I built a platform that would integrate a bunch of different data points coming from this platform called Moves that would have geolocation data and would track a bunch of different activities you would do throughout the day up to, I don't know, Last.fm, and I'd hooked up a Fitbit to my hand for a few months, which was really annoying. So I came up with a couple of different provocations out of this. On the one hand, I was kind of looking at this disconnect that we have from our personal data and how data that can be used to affect behavioral change in a way, things which are very personal to us, live very far removed from our reality. So I wanted to look at ways of remedying that and also discuss a little bit the idea of whether something what happens to us after we die, so more the ephemeral nature of data, but also the transactional data where every behavior that we do in online platforms is basically used to make money by the tech giants. So I made this thing where I could communicate with a thermal printer, and I could ask for it to aggregate my data from these aforementioned frameworks, and to give me a physical receipt from a given date range for my activities. It was a little bit ironic because 3 months after this project, when I wanted to see, OK, let's see if these things, how they look like, and the ink had faded. So it was a little bit of a, it didn't really work out that well to me. Another thing was looking at creating more abstract mappings within data to kind of allow people to reach their targets. So say you want to run a marathon. I would never want to run a marathon, but let's just say hypothetically that you've set a 20,000 steps daily limit. I created this I called it augmented reflection platform, that would, the further away you were from your goal, it would distort your face, and it would try to act as a motivation to engender more behavioral change. So this was prototyped with open frameworks on a Raspberry Pi, and Node.js was running as like the central heart for all the connected artifacts. So I was working full-time until October, and after that I went freelance, mostly because I wanted to give myself a title and a promotion. Basically, I wanted to retire, but the figures weren't really working out, so I'm still forced to work. I used to work at an agency around the corner called RGA. I started working in the data science and visualization group in New York back in 2016 as an internship, and then I had the good fortune to go and work embedded at Brand Studio for a few months in the summer and worked on this project. And otherwise, I was here around the corner. This is a project we did for a nonprofit foundation at Google called Women Will that assessed the gender inequality within the Asian Pacific region. And it would basically, so it had two parts. One was more the exploratory framework. And this bit was the editorialized version, the scroll-telling version, where we used a particle system and different animations to observe and present through the motion of these particles different insights that we found through this data. There are, as you might imagine, some pretty disturbing facts about how people perceive gender equality to look like within these 10 different countries and how it actually looks like. But I'm not really going to talk. I just wanted to give you a context on the kind of work I do. I don't consider myself primarily a front-end developer, but a lot of the work that I do is on the web. I do a lot of stuff with generative design. Obviously, data visualization is a more interdisciplinary field, and that's kind of the context that I like to work through. But yeah, I've also done a bunch of consulting work, just straight web builds, and yeah, more front-end stuff. So before I get to the meat of my talk, I want to make a massive detour. And I think I'm going to talk about an avant-garde group that was active in the 60s in Paris called the Situationists. And just to give you an idea of where their ideas kind of exist within the cluster of Wikipedia, these are the things that they are related to. They were basically a group that dealt with, they were against what they saw as a rising consumerism and alienation within the Paris of the 60s. So they would create these little like playful actions within the city of Paris in terms of how you would be navigating the city, how you can use space in order to waste time. Very playful provocation to kind of go against the whole functional aesthetic that was creeping in within Paris through the architecture and through, yeah, this rising alienation that was happening at the time. So a good way to illustrate what they were thinking is through this movie called My Uncle. Where you kind of have this contrast between the uncle that lives in this really chaotic house, and then the relatives which live in a very geometrical, modern aesthetic, ultra-functional houses where everything has to go in a particular kind of order. They would frequently rearrange things around their house. They would, they kind of thought that there was this oppression and this patriarchy in having different rooms within the house that served a different purpose. So they would try to rearrange, why should the kitchen be the place where I cook? Why can't I just take things from the kitchen and cook in my bedroom? Why do I even need a bedroom? So they were very surrealist and kind of a continuation from the Dadaists, but like this very surrealist group that wanted to come up with these playful provocations of navigating the city. They had this concept called psychogeography, which was the whole idea of, let's say, doing the same thing but for a city. So why, yeah, they would do things like navigate Paris using a map of Amsterdam, or seeing someone with a yellow jacket and just following them throughout the city. And that was their way of kind of annexing their own subjective personal experiences within the objective physical space. They called this act psychogeography. And what you see here is a visual representation of this thing in the form of a map. But this is a map unlike maps you might be used to seeing, because what they would do is they would split the map into different neighborhoods that they felt were very different based on their subjective experience. So it could be that you had 10 situationists just saying, within this corner, I feel these particular emotions. And within this other corner, I feel, I don't know, maybe more confused, maybe more intimidated by the noise and the sound of the city. So they created these kind of conceptual divides around the city, and these lines would be, the thicker a line means the more you would go from one of these islands to another islands. And so in that way, it's a purely subjective representation of the city of Paris. I really liked this idea, and I wanted to get away more from the screen. I wanted to do things within a physical environment, and I really wanted to think about how we think about space in terms of machine learning, where we're talking through the concept of latent spaces, things that have been algorithmically constructed with the goal of putting similar entities within similar places, and the contrast of that with the physical space, where I'm here and you're here, and we can say that we're close together, but that doesn't necessarily make us similar entities. Whereas with algorithmic space, there's always this kind of curation of how we're arranging and organizing different objects. So I thought it would be really cool to kind of do that. I wanted to build a photo portfolio, and I thought I want to escape this whole carousel interaction model. I wanted to see whether it might be possible to bring some of these situationist principles and to create this framework for interaction whereby by walking through a space, you could be navigating these different entities based on a way that I've put them together within space. And the whole idea is, say, for example, you have a square room and you have two people that might be navigating the space, and we're basically translating their coordinates within the physical space and using them to map them to the latent space. So in a way, you're navigating through your physical interactions, the latent space. I started that as a web prototype. You know, this is a traditional way of showing pictures, left to right, et cetera, et cetera. Ah, I forgot to click it. And then I use t-sne. So t-sne is basically this dimensionality reduction algorithm where I created different histograms for all 100 images that I had. And using those histograms, I would take the colors, the four most prominent colors, and I would give them as inputs to my t-sne algorithm in order to translate them within this particular way in space. From there, once you have that concept of visualizing this latent space, you can kind of hover over it and see different things. But my idea was to make this whole thing invisible, so that you would basically be mousing over these Voronoi tessellations, is what they're called, and you would just be going through different neighborhoods of images. By the way, feel free to interrupt me if you have any kind of technical questions. I do have a section where I go more technical, but I did this presentation last week for more of a data visualization context, so I'd be really interested to see how you would approach something like this or what you're interested in hearing about from a JavaScript perspective. I'm more well-versed in Python for doing data science stuff. It's a relatively new field to be doing AI with JavaScript, so I also wanted to show what a proof of concept might look like if we want to start computing this latent space within the front end. And this was kind of what it looks like. So I'm using a package called t-sne.js by Andrei Karpathy. And I'm using these Voronoi tessellations to kind of illustrate the different clusters that are created. And this is the moment where it converges and we basically reduce 12 dimensions. We have 3 different colors times 4, so we're reducing these 12 dimensions into a 2-dimensional space. And the whole idea of t-sne is that we have a high dimensional representation that we want to reduce to a lower dimensional representation while still keeping the relationship of objects and their structures. And this is what it might look like when we start computing the gradients. So this is the whole process where we're kind of stepping through t-sne and until we find some kind of area where there is some kind of convergence. And this can happen through many, like a few thousand steps. And what I'm doing here is I'm changing the proximity. And the proximity is kind of this heuristic that the algorithm uses to understand what are the possibilities of how many different points there might be nearby me. And it uses that to reach the ultimate convergence point. It's basically a way of navigating the local versus the global search space. Here I'm using higher numbers I'm using higher numbers, so each of these cells assumes that they have a larger number of neighbors, and you can see that it changes the way that that final clustering happens. And this is an example. This is from a website online, which I refer to it in the end. It's called distill.pub, but they do really interesting work related to explainable AI or using data visualization to understand kind of how you can tweak different parameters within a model and what are the results that you can get back. And obviously with things which might not be so visual, it's really difficult to understand how you might be doing this so-called hyperparameter optimization. But yeah, this initiative, they try to show from like lower level principles how the different choices that we make as algorithm engineers and machine learning engineers might affect the way that, different clusters in this case are created and the level of exploration that one might need to do in order to understand exactly how they might be segmented in most optimal ways. So moving on, I thought, doing this with photographs is kind of boring. Initially, I wanted to do it with moving image, but there was a step in between, and that was doing it with sound, which I think there's a lot of pre-processing and data engineering that's kind of avoided by doing stuff with sound. I also found some really nice resources. There's this artist called Kyle McDonald, and he made available this data set of 120,000 sound samples that all came in from Free Sounds, which is a royalty-free website that allows people to tag and upload sound samples without any royalties. So I took around 120 of them, which were between 0 and 4 seconds. And what I wanted to do is I wanted to create this 3-dimensional latent space in the same way that I did for pictures. And I wanted to create this exploratory framework where, again, by using the same concepts of the Situationists through purposeless exploration, we could be creating interesting visual and sonic artifacts. So in order to do that, I thought one way of doing that is looking at the pure phenotype properties of the sound. So I can start arranging them based on their frequency or their sonic properties. And that's an interesting project. But what I'm more interested in was kind of looking at this contrast between what a sound might actually sound like and what someone has tagged that sound like. So I used an algorithm called word2vec. And what this does is it's a neural network that's shallow. It's 2 layers deep. And it's trained on entire corpus of Wikipedia. It differs. Obviously, you can train it on many different models. But we're talking about many, many terabytes of text that this has been trained on. And this understands the different structures that words have with each other, so how often they co-occur. And by using those, it can place a word through a vector within a very high dimensional space. This space might be 50 dimensions, or it can be 100 or more dimensions. But what this does is it also allows you to do some really interesting vector mathematics. So for example, you can ask that algorithm, man is to king as woman is to what? And it will reply with queen. I came across this interface quite recently that allows you to navigate these latent spaces through mathematical operations in a way similar to a spreadsheet. So for example, you can average out a bunch of different faces, and then it's going to use a generative adversarial network to come up with the average of these faces. And what this average is basically a way of traversing the latent space and having a vector which is basically sitting in the mean vector space of all of these different entities that you've modeled, and it will then create that visual artifact. And similar, you can do that with words, or you can do that with colors or fonts or anything in between. So what I'm saying is basically, once you have constructed this latent space, and there can be a lot of work in creating the most optimal latent space, or you can even subvert these optimizations to create a conceptually more interesting latent space as one that will produce a more interesting or more provocative kind of artifacts. But once you have that, I'm sure you'll have seen a lot of different art that's made with neural networks where they basically create artificial faces. And these are all different ways of navigating and interpolating through point A and point B of this latent space. So I basically scraped, I created a synonym set for the sounds that I wanted to use. And I came with around 4,000 sound samples in the end, ultimately. And I was looking at sounds that had been tagged with some synonym word from, like, they had been tagged in a way that resembles an urban sound. So I put in a bunch of words, and then I filtered using these words. And most of the things that I was looking at were things like field recording, lo-fi, city sounds. And I think I had a bunch of 20 different synonyms that yielded 4,000 sound samples. And this is what the metadata looked like for each of these sound samples. In case anyone is wondering what the sound of a toilet seat dropping is, someone's recording it, and someone put it up on free sounds. So using this metadata, and this is the computed metadata where I've basically, if you look at coordinates here, you'll see that what I'm doing is I'm taking these tags and I'm constructing a sentence from these tags. And using these tags, I use the Word2Vec embedding to put them within high dimensional space. And then for each tag sentence, I'm averaging out all the vectors for the constituent sentences, and then coming up with a 50-dimensional coordinate point for each of these sound samples within my latent space. Obviously, we can't visualize anything that lives in 50 dimensions, so I'm using t-sne after to reduce that while keeping the original structure to 3 dimensions, and then I'm doing k-means clustering to come up with 12 different neighborhoods. And while I've done this in Python, I did see some things that would suggest it's possible. Definitely Word2Vec can be done with Node.js for sure. K-means clustering can be done in the front end. So yeah, generally, these are things that I think could be done primarily in the front end, and then having a server in the back to do the more computationally intensive computations. I think it could be a JavaScript-only kind of project. The interface looks like crap. This is like 2-3 weeks of work, but what I'm doing here, I'm thinking of this could be used as some kind of tool where if you're an audio producer, you might want to organize and put into some kind of hierarchy in space and visualize all your tagged samples. But what I'm thinking is, what if you could use these samples, and what if you could start navigating different neighborhoods of sound what would that sound like? What if we had some kind of agent that would navigate the latent space the same way a situationist might navigate the latent space? And yeah, what would different neighborhoods of sound like? So I used this sound synthesis engine called Super Collider, where you basically, you can write code in order to make different synthesizers, and you can pass different buffers of sound. So what I'm doing here is, I'm kind of in the middle of it, but I'm creating this bridge using Node.js and WebSockets to pass in these. I'm using Euclidean distance to basically formulate a distance of sound and send from a given source point 20 different sound samples that are similar to it, that are basically conceptually similar because they've been clustered using the tags. And then that goes into a synthesizer. I'm using a thing called granular synthesis, where you basically have this buffer of 20 samples, and it randomly goes from one to the other and chops them up into very small pieces and then rearranges them again. And this is what it might sound like. Basically, the more parameters you can have within these synthesizers, enabling different kinds of performances where you have this interface taking different neighborhoods of sounds, and then you're basically going seamlessly from one to the next, and then you're using that sort of navigation to make different soundscapes. Another neighborhood might sound like this. And it's all generative. Well, one of the things that I was thinking about doing is looking at different other neighborhoods that have been tagged by cities, and in such a way creating the neighborhoods of sounds from only London-specific sounds or from Tokyo-specific sounds, and so on and so forth, and create these different soundscapes for each of these different cities. Or something like that. Chino might not be your cup of tea, but there are many people in the room that enjoy that. So ultimately, my idea is to take this three-dimensional latent space and maybe reduce it again back to two dimensions. Have this room where you can have different people on different ends of the room, and while they're walking in different ways, navigating the physical space, they would also be exposed to the latent space. It would be interesting to find different contrasts, such as populating the latent space with nature sounds on one end, and then taking urban sounds on the other end, and then kind of seeing what it would sound like once we've synthesized both ends at the same time, how that intersection of city sounds with nature sounds might sound. And maybe there's a case where we have two set of sounds that might be conceptually very different to each other, but would yield the same result. So in a way, we're kind of looking at a contrast between the way that we put tags into our lived experiences into different entities, and then the contrast between that and the actual way that they sound and that we experience them with our senses. So yeah, that's it. You should consider following these people. They have really interesting ideas. Their inspiration and some of the tools that they've made were used during this project. Shannon is a really good source for critical architecture and the kind of interplay between urban spaces and technology, looking at that from a critical perspective. Lev Manovich does that with cultural analytics, looking at these things from, again, a more data-driven and creative data fashion, but all with heavy elements of philosophy. Panos is a friend who suggested using Word2Vec instead of just looking at the frequency properties for the clustering. And Kyle McDonald, obviously, yeah, really, really cool work and open source project that he's done. A bunch of references can be found here. I can provide them to Elle if you would like to send them out. And also maybe a PDF version of the deck. Yeah, that's me. Feel free any kind of questions or emails, or if anyone's into making generative soundscapes or would be interested in taking this and help me redefine it more as a tool, I think there might be some interesting ideas there. But yeah, feel free to reach out to me. Thank you very much.
Okay, thank you so much, Zach. That was really, really interesting. Have we got any questions for Zach? Okay. We're going to... Oh.
It's going to be a heckling question.
No, it won't. I just don't catch the name of the tool, the spreadsheet where you can average faces.
Right. Let me see. I think this is called, well, actually it might be here, Space Sheet. So it's here. Yeah, I don't know what the best way to share this would be.
I can send it out, yeah.
Yeah. We can put it on the Meetup.
Yeah.
So yeah, there's a video here, and it still looks very work in progress. But yeah, for example, I think it's a really interesting idea, where you can be putting different words together and using the model of Word2Vec. You can be understanding the different relationships of words with one another. Yep.
Okay, thank you. All right, so we're going to take 5 minutes. If you want to grab a drink, go to the loo or anything, and then we'll have our second talk. But yes, thank you, Zach, once again.
Thank you.